In the problem number 6, a small metal bob of mass m of a simple pendulum of length L is suspended between the two opposite charged large plates. Okay, just like this. And first, if I take this is positive and this is negative, there is a simple pendulum. Electric field E act vertically, but question is not saying upward or downward. Means positive y-axis or negative y-axis. Question is says only vertically. Positive charge Q given to the bob Q, okay, and displaced slightly from mean position, then time period of the oscillation. We know time period के लिए हमें चाहिए effective G. So G plus Q E by M plus or minus. Why I am writing plus or minus? If I take this case, means when upper plate is positive and lower plate is negative, then electric force will act on downward direction. So it will support the force of weight. This time you will take positive. But if I say the lower plate is positive and upper plate is negative, then this electric force will act in upward. So this time you will take negative sign, and time period is given by 2 pi length upon effective G. So maybe plus or maybe minus Q E by M. It will depend the situation of the electric field. So if I go option number 1, lower plate is charged positively, then minus sign will be here. Yes, this is correct. And if I go option number 2, lower plate is charged negative, then no, this is not correct. If I go option number 3, when lower plate is charged negative, plus will be here. Yes, as I discussed. So 1 is correct, 3 is correct. So what will be the correct choice? Option number 4 will be the right choice, 1 and 3. So let's move on. Question number 7. In the question number 7, a positive charge Q is enclosed by Gaussian surface radius A. If radius is increased to 4 times, then net flux, you know, electric flux Q enclosed upon epsilon naught. And this formula will indicate the electric flux will depends on charge enclosed by the closed surface, and there is no length or radius. So it is crystal clear. You can say option number 4 will be the right choice. Remain same. So let's move on. Question number 8. An electric dipole moment P lying uniform electric field E. Okay. The work done in rotating dipole by 37. You know the formula of work done minus PE cos theta 2 minus cos theta 1. Since dipole is lying along the electric field, since theta 1 will be 0 and theta 2 will be 37. So minus PE cos theta 2 will be cos 37 minus cos 0. So minus PE cos 37, you know 4 upon 5, and cos 0 is 1. So when you will solve, you will get PE upon 5. So by this calculation, I can say option number 3 will be the right choice. So let's move on. Question number 9. This question look like very good and difficult, but it is not difficult. Question number 9. A hollow conducting sphere, radius 3 meter, positive charge 1 microcoulomb. Choose the correct plot. Graph means E versus X, electric field versus X. And we know very well, if I go for electric field in this case, then electric field will be kq square upon r square, but when position is greater than of the radius or equal to the radius, means at the surface or outside. But when you will go inside, you know very well that will be 0. When r is less than r means internal point. And you know the electric field is inversely proportional to r square outside of the sphere. So if I go for option number 1, you can observe there is no x square. So that will not be correct, right? If I go, graph number 2 is showing electric field will be constant from center to circumference. No, because from center to circumference there is no electric field. So that will not be correct. Similarly, you can't select option number 3 because option 3 is showing some electric field from surface to center. But अब मुझे पता है कि 4 तो होगा ही. But for your justification, we'll see. E inversely proportional to x square, yes. And how you will get 10 to power 3? You know very well, if I use the formula of E, then value of K 9 into 10 to power 9. Charge is 1 microcoulomb. Divide by 3 square. So when you will solve, you will get 10 to the power 3 Newton per coulomb. And center पे place किया हुआ है. And this graph will justify all conditions. So I can say option number 4 will be the right choice. Let's move on. Question number 10. Question number 10. A wire of length L and charge Q is bent in the form of semicircle. The charge is uniformly distributed over the length of the electric field at the center of the semicircle. Then we know that electric field at the center of semicircle is given by E is equal to lambda upon 2 pi epsilon naught R. We all know this. So if I use this formula, then you know the lambda is equal to total charge and length linear charge density. And you know the circumference is given by 2 pi R. But in the semicircle, I will write only pi R. So that will give you the radius L upon pi. So if you will use lambda and R in this formula, then you will get the lambda is Q upon L, 2 pi epsilon naught R is equal to L upon pi. Pi will cancel, and this L multiplied with this L. So you will get Q upon 2 epsilon naught L square. So this is the electric field. So now I can say my option number 2 will be the right choice. So let's move on. Question number 11.